Hi everyone, and welcome to your 2D Mill class. I am Mariana Lendl, trainer and book developer at In-House Solutions, and I'm going to walk you through the different exercises and projects covered in your Mill 2D class. Before learning how to draw in Mastercam, let's review some basic concepts and terms used in CAD technology. In this video, you will learn how to define elements of the Cartesian coordinate system, understand the difference between absolute and incremental coordinates, and define the four quadrants and the sign of the points lying within each. For Mastercam to display a part, you must define its exact shape, size, and location. You can do this by drawing lines, arcs, points, and other geometric entities that precisely describe the part. These geometric entities exist in a Cartesian coordinate system. A Cartesian coordinate system consists of two or three perpendicular number lines known as coordinate axes. A number line is a line divided into equal segments. The point on the line designated as 0 is called the origin. The Cartesian coordinate system allows you to define each point uniquely in a plane using a pair of numerical coordinates, which are the signed distances to the point from the origin, and they are measured in the same unit of length. Numbers to one side of the origin are positive. Those on the other side are negative as shown. Note that it is common practice to drop the sign for positive numbers. A two-dimensional Cartesian coordinate system consists of two number lines set at 90 degrees angle to each other. One line is horizontal, left to right, and is labeled as the x-axis. The other is vertical, up and down, and labeled as the y-axis. The point where the axes cross is the origin. All points in this space, also called a plane or construction plane, are precisely defined given its axis label, sign, and value. For example, the point at x3, y2 is located by counting from the origin 3 units along the x-positive axis, then up 2 units parallel to the y-axis. Cartesian coordinates may be written in two different ways. One uses the x label, sign, and value. For example, x3, y2. The other writes coordinates as an ordered pair. Numbers are written in a specific order, x and then y, separated by comma. For example, 3, 2. If the point is defined in 3D, the coordinate of the z value should follow the y value. Absolute coordinates are always referenced from the origin, regardless of the previous position. Starting at the origin, the diagram shows a move to N1 and then a move to N2, both written in absolute coordinates. Incremental coordinates, sometimes called delta or rectangular coordinates, are always in reference to the current position. In this example, you can see a move to N1 starting at the origin and then a move to N2 written in incremental values. Polar coordinates are always in reference to a position called the anchor point, a distance, and an angle. Starting at the position x2, y2, this figure shows a move to N2 written in polar coordinates. Angles are measured in degrees from 3 o'clock position as shown. Positive angles are measured in the counterclockwise direction, while negative values are measured in clockwise direction as shown. A plane can be divided along its axis into 4 quadrants. Starting in the upper right corner and moving counterclockwise, the quadrants are labeled 1, 2, 3, and 4. It is important to know which quadrant the part is in because the sign of the coordinates changes based on the quadrant. As shown in the figure, all points in quadrant 1 have positive x and y values. Points falling in quadrant 2 have negative x and positive y values, and so on. This concludes our first lesson.